In this video, we're going to look at graphing linear equations. Now, this is just an overview of what we're going to do in a couple of other videos. So if you want to skip right to those other videos, that's okay too. Graphing the equations through finding points and graphing the equation through the slope-intercept form of a line are going to be the other two videos after this. Now, when we say graphing linear equations, our linear equations are going to focus on equations with two variables. Usually those variables are going to be x and y. You can technically have any variables that you'd like, but we would focus on x and y. Now, the idea of a linear equation is one that is obviously linear. So it's important to understand what the word linear means. Linear is referring to the variables in my equation. If I'm dealing with two variables, x and y, then linear equation means those variables are going to be raised to the first power, and also that we don't have any division by any variable. Coefficients, on the other hand, could be any number. So for instance, something like 4x minus 7y equals 23 is a linear equation because we have x and y. Both are raised to the first power. Again, if we don't see an exponent, we assume it's 1. And we don't have any division by the variable. Y equals 3x plus 4. That's another linear equation in terms of x's and y's. 4 times x minus 3 plus 8 equals 1/5 times y minus 6.7. That's also linear. Again, you look at the variables x and y, they're both raised to the first power. You're not dividing by x, you're not dividing by y, so that is linear. Again, it's okay to divide by a number like this 1/5, we're dividing by 5, but it's not okay to divide by a variable if we're talking about linear. Our goal is to look for solutions to that linear equation. And a solution is an ordered pair or a point which makes the equation true. So we're going to look at solutions. So for example, if we take the line or the linear equation y equals 3x plus 4, if you plug in the ordered pair -3, -5, that is, I plug in -3 for the x value and -5 for the y value, what you'll get is a statement that says -5 is equal to -5. That's obviously a true statement. So that point is a solution to this linear equation. Whenever we write points, we write them x, comma, y, if we're dealing with variables x and y. It turns out -3, -5 is not the only solution to that linear equation. In the linear equation y equals 3x plus 4, if you replace the x with the number 1 and the y with the number 7, so in other words, plug in the point 1, 7, you also get a true statement, and that means 1, 7 is also a solution to y equals 3x plus 4. Now, there's lots of points that are not solutions as well. Those are points that you plug in, and it leads to a false statement. For instance, if we plug in 1, 9 into the equation y equals 3x plus 4, Plugging in 1 for x and 9 for y yields a statement that has 9 equals 7. Obviously, 9 is not equal to 7, so that's a false statement. And therefore, 1, 9 is not a solution to that linear equation. Now, I've been saying the point is a solution or is not a solution to the linear equation. Linguistically, oftentimes when I talk about it, we will say the point works for the equation, or a little bit later we'll say the point is on the line. So a point being a solution is the same thing as when I say a point works in the equation or works for the equation. Now, a question we may ask is, we have this equation, y equals 3x plus 4. We saw that -3, -5 was a point that worked in the equation. We saw that 1, 7 was also a point that worked for the equation. How many points are there that work? Well, it turns out you can keep getting more and more points. 0, 4 also works. 2, 10 also works. 0.4, 5.2 also works. In fact, there are infinitely many ordered pairs that are going to work. If we have an equation in 2 variables, we're going to end up with infinitely many ordered pairs that work. So because we end up with infinitely many ordered pairs that work, we can't actually write down all of the ordered pairs that work. So what we're going to do is we're going to graph all of the solutions. Graphing ordered pairs requires us to put points on the Cartesian coordinate plane. If you don't know what the Cartesian coordinate plane is and how to graph points on that, I will link a video to the Cartesian coordinate plane in the description below. But essentially, what we do is we take our points, -3, -5, 1, 7, 0, 4, 2, 10, 0.4, 5.2. And we make a point on that Cartesian coordinate plane. So we make a point on the grid for every point that I have. What you'll notice if I do that, all of these points line up in one straight line. It turns out that every linear equation in 2 variables will have their solutions. All of the points that work will line up in a straight line. And so what we will do is we'll connect these dots. And not only are those 5 points solutions, but every single point along this line is a solution to the equation y equals 3x plus 4. So there are infinitely many points, and they all fall on that line. Now, in terms of graphing, when we do create the line, one way to phrase it is that we are graphing the solutions to the linear equation. Another way to phrase it is that we're graphing the line. So we often say, well, this equation is the equation of the line, or some people will just say this equation is the line. So we kind of loosely use those terms interchangeably, graphing the line or graphing the solutions to the equation. Now, in the next couple of videos, we'll take a look at a couple of different methods for how to graph the line. I've kind of hinted at the first method already. That first method is called the table method or the finding points method. The second method we'll use is the slope intercept form method for finding and graphing the line.